Hello and a very warm welcome to the first of a two-part webinar on edge computing. We have a superb lineup of panellists from across the globe exploring edge from multiple industry viewpoints. We'll be speaking to them shortly. My name is Stephanie Parker and I am Vice Chair of the 5G Infrastructure Association Pre-Standardization Working Group. Joining me on this webinar today as co-chair is Dr. David Lund, President of the Public Safety Communications Europe.
My name's David Lund. I have the pleasure to co-chair this session today with Stephanie. I'm from PSC, Public Safety Communication Europe Forum. And the edge computing topic for us feels a little bit futuristic, but you know we can start to anticipate how we take this forward for our community, that's for sure. Responders, public safety responders from our side, we need better broadband mobile communication and we're rolling out across Europe. It's in its preparation right now. Innovation ecosystem, certainly Edge is part of that, and we see this as a key goal within our work. But as I said, it's a little futuristic in our concept for us, but does raise some interesting discussion. So what do we say is edge computing? You know, I'm sure you'll hear more from our speakers today. I understand this as a mechanism that brings compute power and information to the edge of a mobile network. I'm going to talk from a vertical perspective, not necessarily a technical one, but very briefly. And close to that mobile base station and doesn't have to rely on the processing and battery power of a mobile device. It allows for low latency computing response, the information captured on sensors and mobile devices, and we would hope to allow for that fast feedback to those which may make important decisions with that information and maybe with data analytics that runs on that. So in my context, think of a future firefighter. He's wearing a smart protective mask and suit. The mask and the suit has many sensors. It could include thermal cameras, LiDAR, body sensors. They sense that environment of that burning building and with precise accuracy. Things can happen very quickly in a burning building, as I'm sure you can understand. So sensor data transferred to the edge, complex analytics on the edge, studying that environment and provide immediate warning of fast developing danger to display on the firefighter's mask. So that low latency communication, fast analytics on the edge could help one of our firefighters to respond in a fast accident incident and even save a firefighter's life or someone else's life. So I'm sure you'll learn a lot more today about the edge, and I sincerely thank all of our speakers in advance. So I'll hand you back to Stephanie to get things started.
Yes, thanks very much. In fact, the 5G Infrastructure Association and PSC are two of the webinar organisers as part of a series along with 5G Automotive Association and the 5G Alliance for Connected Industry and Automation. And these organisations are both represented in the webinar today. So thank you, David, for the introduction and those insights of what edge will mean for the public safety community. My colleague John is now launching our first poll to understand where you all sit in terms of implementing edge computing. So I think we can go with the first poll, John. And John, perhaps you'd like to introduce yourself a little bit more to the audience as co-host of this webinar series, but not just this afternoon. But
hello,
you're linked to automotive particularly. Yeah.
Yes, thanks. My name is John Favre. I'm Stephanie's colleague, and I am involved in particular in the vertical sector of automotive. I'm a member of the 5G PPP Automotive Working Group, and I work together with the colleagues there in determining future directions and what we want to do in the 5G PPP.
Oh, so that's an interesting one. So most people it's quite close though on the last three, but most people are still at the early learning stage. So we hope this webinar this afternoon will help you do that and to understand more about what it means in terms of your organisation. Okay, so thanks very much. And I'm going to pass the floor now to Dr. Leonardo Gomez Baltar, who is Vice Chairman of the 5G AA Working Group 1 on use cases and requirements. He's also lead of the MEC 4 Auto working item on edge computing for automotive services. We'll be talking about enabling edge computing to support cellular V2X use cases. So a very warm welcome to you, Leonardo. Who I'd just like to add, Leonardo is also a delegate and contributor to ETSI Technical Committee Intelligent Transportation System, ITS. Leonardo, thank you very much. The floor is yours.
Thank you very much, Stephanie, for this kind introduction, and thank you very much also to the organizers for inviting us and allowing to present or give at least some taste about the activities in 5GAA on edge computing. I hope I can give some introduction here, but I really encourage you to look after material I will refer here to in order to deepen your knowledge. And let's just start. So basically you see from the title that we had a work item in 5GAA called MEC for Auto, and this has been the main framework where we have been developing edge computing activities inside of 5GAA. So why 5GAA decided that, you know, a dedicated work item was necessary? I think what the first bullet says here is, should be quite known to most of you who are interested in this webinar, which is what exactly edge computing means. And basically it means we are providing then cloud computing capabilities at the edge of the network, right? And 5GAA has considered in the past and still considers today that edge computing is one of the key supporting technologies for many of the CV2X or V2X services for connected vehicles and automated driving. Nevertheless, there are still some challenges for the successful deployment and use of edge computing for V2X services. And those are not necessarily just of technical nature, right? There are challenges from a business perspective for sure. There are challenges from a standardization perspective. There are challenges on the ecosystem and the connections inside of the ecosystem. And also in some cases, depending on the specific service, there are also regulatory challenges, right? Let me just briefly tell you where did we start in 5GAA with edge computing. We did not start out of nowhere. There was some background. As soon 5GAA decided this is an enabling technology that we should investigate better. There was a first effort on writing a white paper back in the end of 2017 that was published and look at different aspects like use cases and some business models. It was a first tentative to connect all these industries around automotive together with telecommunications and vendors to look into how edge computing might be useful for this industry. And later on, subsequent to this publication, there was a workshop in February 2018 here in Munich, where I'm based actually. And in this workshop, lots of conclusions or discussions happened. After that, it was clear we need to have some framework in 5GAA to work on edge computing. And that's where MEC for Auto was basically born. We then prepared this work item, and here I just show you a small piece of text from our use case description, which more or less try to set the scope in MEC for Auto. The scope is for sure to demonstrate edge computing for automotive services, but not in any environment, right? It is a very diverse and multi-stakeholder environment where multiple automotive vendors are exchanging information via edge computing. multiple use cases for sure. And as you know, wherever you are in the planet, you probably have multiple network operators serving also different equipments or different vehicles, right? And of course, as it's usual in cellular infrastructure, you have multiple vendors as well as in the vehicle side. So it's a quite challenging environment and quite let's say ambitious objective we had. Doesn't mean we wanna fulfill all these objectives in this single work item, but at least the high level on the long term, we should be able to do that, and we have been working on that. And I would like to show you a little taste about what we did so far. So this is just a pictorial description on how the overall environment looks like. What we can see here is that we have multiple vehicles from different OEMs. We have multiple cellular networks. We have the different OEMs backends. We have the road infrastructure, and possibly also multiple road users, such as this pedestrian or bicyclist. So it's a very, very heterogeneous environment we are working on in the automotive application. So how the work was structured in MEC for Auto? We had one stream which was basically look at the use cases and the requirements review, and also we did some selection of use cases to analyze and evaluate. Of course, there is a very a long list of 5GA use cases that you can also find on 5GA portal. We need to do some down selection, discussing with car OEMs, in order to make sure we are taking relevant use cases. Of course, there is no target there to be extensive and able to enable all possible use cases, but to have some ideas on how it should work for some of them. Then we have another area where we studied really the deployment options, interoperability matters, and security and privacy aspects. And I'm glad to tell you, this is a very recently published document we have from stemming from this activity. I have added here the reference. Maybe you don't need to note this, but if the slides are made available, you can just click. But if you go to 5GA portal, you can easily find it if you search for the studies. And very soon we will have also the first activity I mentioned before on use cases published. Another one we have been working is on demonstration activities, where we have been planning some demonstrations on a multi-MNO environment. And another activity we are also preparing a publication was on the study on the business models or business aspects and go-to-market strategies. This is also a very interesting and probably for the interest of many people on how this actually works. So we did that type of study as well in this work item. So I would like to just give you some taste about how the study on the deployment options look like, and you can look into more details in our published reference here. Basically, we have looked at 3 basic scenarios. And imagine you have vehicles from 2 different OEMs on the road, and those are attached to different MNOs. Those mobile operators, they have some associated edge computing infrastructure, and they have an application running in this edge computing infrastructure. So let's assume that we want to realize a use case that needs some exchange of information between the 2 applications here. And the first scenario assumes both MNOs are equipped with edge computing infrastructure, and the app is also there. How do we make sure that the data between the 2 applications on the 2 MNOs exchange data efficiently? On scenario 2, which is also possible. Maybe one of the MNOs, in this case here, MNOB, does not has application, the application of interest in this case, installed in its edge computing infrastructure. So how can we make sure that this green car gets served or gets the service from this application? This is what we call scenario 2. And then finally, we have scenario 3, where basically now the MNOB is not even equipped or has no local access or in its own network to an edge computing infrastructure. Now it needs to fully use the edge computing infrastructure associated with MNOA. So that's basically scenario 3. And you can find all the details in our published work. I think that's what I brought to you today. Thank you very much. Last word is that I encourage you to visit 5GA portal to see the many white papers and studies available. It's really recommended. We have a lot of interesting things there if you are interested on the automotive vertical and 5G. Thank you very much.
Leonardo, we have a question in the panel that we've got a couple of minutes, so well done for keeping the time. The participant is asking, what do you consider as edge computing infrastructure?
That's a good question. So basically what we assume is that, you know, typically there is some sort of domain we define for a specific network operator, right? And then if you look at the network operator infrastructure or architecture, there are things which might be inside of their own infrastructure, and there are things which might not be. Typically, for example, here in this figure, if we look at the OEM backend, which is the computing server of the OEM, this will be typically not something you have inside of the MNOs, right? Because this is serving cars everywhere in the world. So this is typically something, it's not part of the infrastructure of the MNO. So when we say the edge computing infrastructure, are basically saying those servers are located in some part of the overall network, which is not inside of the domain of this MNO, right? So that's basically, I hope I could somehow answer to the question. But for sure, if you open our document, you will see more details on where, let's say, those borders are drawn and how do we consider whether it is in the domain or not. I mean, technically, we have more details in the document, which probably better answers your question.
Yes, thank you very much, and thank you very much, Rahul, for the question in the panel window. Okay, so thanks very much, Leonardo. We now turn our attention to open source perspectives with Gabriel Yang, who is Technical Steering Committee Chair at Edge Gallery. He'll be telling us about Edge Gallery's approach to 5G open source and its applications in the industrial Internet of Things. Thank you, Gabriel, and thank you for accommodating your schedule to be here with us today. Please, yeah, you can start your presentation. Thank you.
Okay,
Thank you very much.
start my sharing. So basically, Edge Gallery is a open source initiative for 5G edge computing. This is the contents of my presentation today. Basically, I will introduce the background and the architecture of Edge Gallery and also the application in industrial IoT. This is the background of why we consider Edge Gallery, why we start the initiative with in this 5G edge computing. So we basically we think for the 5G, the new 5G network for the business ecosystem, there is no platform or at least a unified platform for to build a unified ecosystem for enterprise digital network or digital transformation, not only for the verticals, but also for the operators. So basically, we think for the NFV, considering the NFV, the interoperability will take very much effort. So not only one the companies or vendors can deliver a overall solution, but in a 5G edge computing MEC, 5G MEC scenarios, that we don't want this happen again. So we start this Edge Gallery open source community to have a unified system, ecosystem for the edge compute, 5G edge computing. This is the overview of how the standards cooperate with each other regarding 5G MEC. Basically, 3GPP focus on the core 5G core network, but ETSI focus on the edge computing part, while GSMA focus on the interoperability or interconnection with different operators. But all these scenarios, all these fields need some standards, at least some introduction or some paperwork for all the vendors or companies are interested in these scenarios in this MEC, edge compute 5G MEC scenarios. This is the overview of Edge Gallery. Basically, Edge Gallery is compliant with 3GPP and ETSI. Edge Gallery had 4 components, including the edge computing component and the edge management part. These 2 components are compliant with 3GPP and ETSI. We also have 2 components that are developed by our company, our Edge Gallery community. One is the App Store. One is the application store. This is actually an application repository. Now this has more than 80 applications on board. We also have a developer portal. In this developer portal, we have SDKs, we have tool chains to ease the development of application on 5G edge computing. So basically, these are the 4 components in Edge Gallery. I also shared an introduction video, demo video in the chat box. If you're interested, you can go to that YouTube link. There is a brief introduction video. It will give you a brief idea of Edge Gallery, how the 4 components working with each other in 3 minutes. Now, Edge Gallery is started from China, but we have plans to go abroad this year. We have 8 senior members, including the vendors from China, China Mobile, China Unicom. Some of the vendors are also apply Edge Gallery in their commercial environment. We now have more than 25 members. The numbers is continue growing, while the application integrated, a number of the application integrated is also growing. Developers that participated in Edge Gallery is more than 200. We also have some developers that are some architect that are involved in the community. We have more than 400,000 lines of code now. If you are interested, I will also share the link at the end of my presentation that you can see the codes, and you can see all the designs, the discussion within the community. So the architecture of Edge Gallery, as I mentioned in in the formal slides, there were 4 components in Edge Gallery, which is in correspond with the 3 phase of development. The first is the application design phase. We have developer portal to give developer to ease the development of application, and we provide SDKs, we provide APIs, and also we will provide guidance, the guidelines for vertical vendors to develop their application on 5G edge computing. We also have the application distribution phase, which is more related, more relevant to the edge computing management system. All the application, including the life cycles, including the resource monitoring, will be will be developed, or the components will are all included in the MEC management part, called MECM, which is in short. There were also a application running phase. This is the most is related to the MEP, which is the MEC platform. It will be installed on edge node. It supports both container-based or virtual machine-based applications. It will provide the certification or authentication of API calling, and also provide a health check, provide open capabilities, including the AI capabilities or 5G network capabilities. All these capabilities will be provided by the MEP platform. These are the 3 development phases in Edge Gallery. So Edge Gallery is basically an edge computing platform, open source platform. It has several use cases. For industrial IoT, we have planned that to integrate Edge X Foundry and Fledge to support the factory use cases. This is the one use cases of Edge Gallery in Lighthouse Factory. It will support OPC UA with TSN, and it will also support some user end protocols in factory scenarios. And Edge Gallery can be easily integrated to the IT and OT system in factories. That we have some plan, and we also have some experience in these scenarios. If you have any questions, we can answer in a panel session. This is another use case in industrial IoT of Edge Gallery, is in industrial vision system. Mainly focus on quality inspection. We have some image compression SDK that could be embedded or included in the camera, that with the continual snapshot of the object, Edge Gallery can provide application to do the quality inspection within the factory. So this is another use case. Actually, there will be many use cases that is dependent on the application on Edge Gallery. One of our downstream project that is hosted in Linux Foundation at Crino will focus on the PCB quality inspection, and also some a smart DC monitoring. It's not limited to this industrial IoT scenario, but today I only listed some use cases within the IoT scenarios. In the meanwhile, the Edge Gallery community provides a developer portal to accelerate or to ease the application development to provide a pipeline to accelerate the development and rollout progress. If you have time, you can see that YouTube link I shared before is at the overview of the development pipeline. So now Edge Gallery works extensively with upstream and downstream industry organizations, including Link Foundation Edge, the MSA, ETSI. We have attended the ETSI plug test and run all the interoperability test cases on regarding MEC. We have the China standard organization to build standards based on Edge Gallery. We also have a national-wide lab to have the test playground of Edge Gallery. We have also released some white papers based on Edge Gallery architecture. Yeah, this is the takeaway from my presentation. I think I can share my slides after the webinar if you are interested, but this is the page that you might be interested, all the links that related to Edge Gallery, so including some books and the WeChat group. Okay.
Okay, great. Thank you very much, Gabriel. That's very interesting. So I'd like to hand over now to Nurit Spreker from Nokia, and is a founding chair of the ETSI MEC working group. So please, Nurit, can you take the lead?
So thank you very much for the opportunity to present today. Obviously, it's a very short time to provide the entire storyline, but I'll try to give some pieces such that it will still some interest and we can continue the discussion afterwards. So I would like to talk to you today about multi-axis edge computing, which we believe it's a common and extensible application enabling platform for new business opportunities. So what is it about MEC? Edge computing in general offers cloud computing capabilities and IT service environment at the edge of the network, constituting of a powerful catalyst for innovation, unparalleled user experience, and lucrative business opportunity. The edge environment is characterized by ultra-low latency, by proximity, by high bandwidth, and the IT economies of scale can be leveraged to allow proximity, context, and agility, and speed to be used for wider innovation that can be translated into unique value and revenue generation. For example, interactive and delay-sensitive applications such as gaming, augmented reality, or indoor navigation located in close proximity to the users can benefit from increased responsiveness as well as maximize the speed and the interactivity. Obviously, low latency, very high volume of data messages is delivered with minimal delay in near real time can be ensured for critical communication, for example, in industrial environment. Real-time analytics can be performed at the point of capture and corrective actions can be instantaneously taken locally. And furthermore, the Edge platform, as ETSI MEC defined, can provide insight of real-time network and context information that can be used to optimize the network and do service operation and proactively maintain the customer experience. So, for example, being aware of near real-time capacity available at the radio downlink interface, a video server can intelligently maximize the utilization of the precious radio resources and accelerate the video delivery and improve the video quality and eventually the user experience. And the overall MEC enables a myriad of new innovation and new innovative application and services across multiple sectors as well as innovative business opportunities. So it's actually, if we look at that from abstractive level, we have the network, the edge, the RAN network, for example, which is a best-in-class RAN with also can be real-time radio optimization, which is enabled, for example, by RAN intelligent controller. And on top of that, we create the service environment, the application platform, and we can expose the MEC value-adding APIs to applications that are running there or even connected by remote. connectivity. So this is a service environment for enterprises, verticals, and application ecosystem. So MEC also support a multiple and flexible deployment option. It can be deployed at the hotspot to support zone applications, such as, for example, special services in stadiums or exhibitions or malls or enterprise campuses. It can be deployed at metro aggregation sites and basement hotels to support citywide applications such as video analytics used across the city, or IoT application used to monitor a smart city infrastructure. And it can also be deployed in a more centralized location, for example, the Cloud Run, or in specific deployment pattern. And by the way, also in the centralized cloud, and it can also support network-wide applications, for example, as we heard before about the car-to-car or car-to-infrastructure along the roads. So a little bit about ETSI MEC. ETSI MEC enables application in a distributed cloud environment. So where we are in terms of standards, I can say that the foundation for edge computing was created. It is, we have a fully standardized solution. Of course, it is extensible, and we enhance and add more and more capabilities as needed and as required by the different use cases, for example, by 5G AA and hopefully soon by 5G ACA. Etc. And in order to enable application in distributed cloud. So ETSI MEC has defined, and this is of course a very high level illustration, 4 components. One of them is application enablement or API framework, where you actually can deliver services which may be consumed or offered by locally hosted or remote authorized applications. It enables service registry, service announcement, discovery, and notification. It allows to authenticate and authorize the application we provide and consume the services, and it provides all the communication support and services that are needed based on query response and notifications. It also includes APIs principles and guidance, which guide us how to develop and document APIs inside ETSI, but also outside ETSI. It's ETSI environment support. Bring your own service, and allows also some services to be defined somewhere else. But the idea about the API principles is to ensure that we have a consistent set of APIs that can be used by developers. The APIs are designed to be application developer friendly, because it's very important that they will use that, and easy to implement as to stimulate innovation and foster the development of the applications. And then we have service exposure via standardized APIs. So we have a different set of services which may be applicable, by the way, at different locations. So services include today radio network information, abstracting the radio information, wireless LAN information, fixed network information, location information, V2X information, IoT information, and any other service that can come in the future. And of course, we have other services as well. And then we have management, orchestration, and mobility-related APIs, which facilitate the running of applications at the correct location at the right time, based on technical and business parameters, and it also ensures service continuity. ETSI is a key enabler of 5G. It is expected 5G performance attributes, in particular end-to-end for end-to-end use cases. And we made sure that ETSI MEC, or MEC in general, is considered in the 3GP 5G architecture from the beginning. And SA2 in 3GP has defined enablers for MEC, considering that as an application framework. For example, it allows us to select the user plane function, which is closer to the UE. It allows reselection. It allows support for traffic steering locally per UE or per group of UE. It supports local UPF access to applications, deliver of UE mobility information to trigger UPF reselection, etc. So there are a lot of documentations about this, white papers that you can look how to use these enablers in order to integrate MEC in the 5G. So you could find MEC in the very edge, but you can also find it in a centralized location, and we also ensure that it communicates nicely with the 3GPP environment. ETSI MEC is a group with 110 members today, which represent the different players in the industry, different stakeholders, the operators, technology vendors, IT players, the industries, and application developers. Notably, we could mention that in the last year, Apple has joined, Qualcomm has joined, we have Bosch here, and many operators. Verizon joined last year, etc. So it is a growing community, and it is done in a very healthy space. So what actually ETSI MEC provides, it provides the openness foundation, open architecture, open APIs, and open ecosystem. It provides a common application platform that you can use to plug and play applications and on every infrastructure platform. So it's actually handling the application layer, application platform. It is extensible platform. It is aligned with the overall cloud transformation and a natural element of 5G. As we said, it can be brought to all locations, and it can also be deployed in different cloud environments. And it is keystone of the URLC transformation. It enables a new class of premium SLA services and applications, and support the digital transformation and mobilization of the enterprise industries. I will skip a little bit because of lack of time. So if we try to summarize what we have now in ETSI MEC, we have mostly around 50 document or publications, more or less. It includes indications how to integrate MEC in 5G, security aspects, federation to support, for example, the V2X and MEC for Auto or G MEC for Auto, and it allows interaction between MEC systems, MEC platforms to support this multi-operator, multi-network, and multi-vendor environment. It is an operator-driven work in ETSI MEC. We have a testing framework. We have a support for mobility. We have a lot of white paper which describe different deployment options and solutions where you can use the different ETSI MEC specifications. We work to establish the ecosystem with open APIs, which are available at the ETSI Forge, and allow you to experiment the APIs, understand the value. It includes a sandbox environment, and we run a very successful MEC hackathons. And we know that it's also openly available. We just heard about the Edge Gallery that implements and compliant with ETSI MEC, and also it is available in the Linux Foundation Akaino project. We have some blueprints there, and we actually move from proof of concept to proof of viability in a live network environment. Attracting the developer is key. They need to understand the value of the services. They need to have some tools to play with that, to experiment. They need to have a community to work in, and they need also to understand how they can make a value of this. And of course, GSMA has worked a little bit about this to understand the business opportunities and monetization options for MEC. I will skip the MEC in 5G because I described it, but I want to talk, and this is a very important aspect, and I'm happy that I've seen that with the Edge Gallery presentation before. The idea is that as we evolve, the acceleration of related activities in the industry is growing, and we wanted to take a further leap toward with moving to harmonized standards. AECC has started working on Edge, and we work together with the between the ETSI MEC experts and the AECC experts to create a synergic architecture, and we documented that in by the way, in the document in the annex here, but also in a white paper that came from the officials of these groups and the key players. Many companies co-signed it. And we actually indicated how to use the synergic architecture and different components of it in different deployment options. So I recommend you to read that. MEC is the key building block for V2X services, and we have the MEC for Auto and G MEC for Auto in the 5G AA. 5G ACA started working on industrial 5G compute edge use cases, requirements, and deployment models, and we hope that they will leverage ETSI MEC specification and will provide us with more requirements that we can enhance the ETSI MEC to support their needs. And I want also to indicate that ETSI MEC is defined, and the synergic architecture is well positioned to satisfy the needs of the GSMA operator platform as specified in their documents, and also the NGMN future network cloud native platform, and help monetize the operator network. The GSMA document actually leverage ETSI MEC or acknowledge the role of ETSI MEC in providing the hosting environment and supporting these APIs towards the applications. And also this Mosel Forum has worked on the Edge Cloud and referred to the ETSI MEC. So we try to harmonize the industry activities. This helped to to accelerate adoption at scale. And then this is the synergic architecture. You can see these are the parts that are coming from the ETSI MEC, which is focusing on the MEC applications, the communication between the MEC platforms, the MEC platform and the communication between the MEC platform and the exposure of information to the applications, and also all the API framework, the application enablement, and then all the orchestration and the management of the applications. And we also support the possibility to offload applications from the device using the MX reference point. I just want, because I'm very limited in time, I just want to highlight that Nokia took it a additional step when they actually decided to combine the ORAN real-time, run near real-time run intelligent controller and the MEC platform on a single platform and provide application awareness of the MEC combined with the run awareness of the RIC. So we actually can expose the information, understand the run situation, and further abstract it to the applications using the ETSI MEC specifications, and then we can understand the application interest and needs and the status or whatever, and use this information to help us to optimize the run. So it becomes a network-aware application and application-aware network. And it is compliant on the one hand with the ETSI MEC APIs specifications and also with the ORAN specification. So we have a common platform where we run both the RIC applications and the MEC applications with full compliance both to MEC and to ORAN, and we actually create this environment that is creating additional value. It is infrastructure independent, it's a containerized platform for innovation, and of course we have leveraging AI machine learning services in order to provide additional value. So a little bit to epilogue on that, to provide my epilogue on that, and of course I have much more to say, but I was limited in my time. So it's very clear that there are vast business opportunities at the edge, and we actually can say that MEC is taking off. We have seen the Delaware a positive report on the growth of MEC. I think one of the contributions to this update of the forecast was this synergic architecture that we have created together with the AECC and ETSI MEC. MEC is coherent with the openness submission for innovation and growth. It provides a common API framework for third-party plugins and open APIs for data exposure and programmability. We need to remember that the developers want to see common practices, how to develop applications, how to use this information and how to access the APIs or whatever. So it's very important that we follow a common API framework. MEC is aligned with the overall cloud transformation, and it is a natural element of 5G. It is a key enabler for IoT and mission-critical vertical solutions, and it is a focal point of collaboration between operators and enterprises of this service environment. The fundamental specification of ETSI MEC are ready. It is widely recognized in the industry as the leading SDO for application enablement and edge computing. It is well positioned to satisfy the needs of the operator platform and help monetizing the operator's network using MEC APIs. It is flexible and extensible, so as we have identifying more and more requirements and more needs, we can help to extend the capabilities and ensure that we can satisfy these needs. And the number of edge initiatives in the industry has considerably grown, and they should leverage MEC to ensure that we have common practices, common tools for the developers, and this will help to ensure adoption and acceleration, and accelerate also time to market.
Thank you very much, Nurit. You do have the honour of being the first woman panelist on our webinar series, so congratulations. We'll move swiftly now on to the next lady on the webinar series, and that is Sumita Chakrabarti, Verizon Technical Lead Delegate and Rapporteur at the 5G ACIA. Thank you very much, Sumita. The floor is yours.
Thank you very much, Stephanie, for introduction. Okay, so we are going to talk about the 5G ACIA. initiative on industrial edge computing. And I'm Samita Chakrabarti from Verizon. It's a short introduction about me. I work in the technology strategy and planning as a standards architect for industrial IoT and 5G. Besides being a technical lead delegate at 5G ACIA, I'm also the rapporteur of the industrial edge use cases and requirements study that 5G ACIA has introduced end of last year as a strategic goal. Also, I'm involved with GSMA IoT manufacturing group and IETF in the IoT area. So to give a short introduction about 5G Alliance for Connected Industries and Automation, 5G ACIA. For those who are not so familiar with it, so this is the organization which is trying to understand and integrate the requirements that are coming from Industry 4.0 and trying to see how those requirements can be mapped with the 5G systems, 5G technologies coming out of 3GPP. So basically, we spend a lot of time analyzing the 3GPP specs and the industrial 4.0 requirements for the manufacturing process industries. We create reports, technical reports, white papers. Now we started doing test beds and also extensively communicate through liaison statements, contributions to the relevant standards organizations. So the structure of 5G ACIA is, as you can see, it has a board. Currently, the board has 15 members, and in addition to general chair and vice chair, Verizon is a member of the board as well. Working group 1, so they have 5 working groups. Mostly the work is done on virtual meetings, and then the decisions are taken at the plenary meetings, and they also have annual general assembly for the decisions and strategies. So working group 1, where edge use cases being discussed currently, they are the one for use case and requirements. Working group 2 deals with the spectrum and operating models for the SAIA. Working group 3, architecture, technology, and as a next step of the edge computing use cases, once they're pretty much selected, discussed, understood, will be taken over and use that as a basis for defining some of the deployment architecture that using the 3GPP and ETSI MEC recommendations. And then liaison and dissemination in group 4. Group 5 actually handles the test labs, test specification, test validation strategies. Now we are working on some of the other aspects as well to work towards a common test bed among some of the members and maybe some non-members as well. So I think it's quite interesting and fun group to work with. For the edge computing studies, as I mentioned that last year we had introduced a strategic goal at the board level and to understand the implication of edge industrial use cases and their requirements and how it can be deployed in SCIA configuration. The typical SCIA, the industrial use case, is a little different than what we have seen before, like in 5G AA, where mobility is a concern. Here, the mobility is there as well, but a lot of times it is limited in the factory, and that factory could be several square kilometers, or a small one. But then there are process industries as well. But we need to understand all the relevance, what are the selection criteria for choosing an application to run on multiple configurations of the industrial networks. For example, it could be private networks, completely standalone, or it can be also, it can be like mobile network, MNO assisted private networks. So that's the goal of our initiative, and we are going to look into the several aspects like latency, whether it's low or ultra low latency requirement, compute storage, offloading, performance bandwidth, and also security requirements between the applications, devices, 5G systems, APIs. And location of edge is very important for 5G SCIA because most of the time they want their data to be inside the factory, and in some configuration, control can be located in the MNO space, but the data can be inside. And even if sometimes the edge and 5G systems are offered by a service provider, there are requirements where these should be located. And also I would like to mention that one of the things that 5G SCIA does well is to work with the SDOs and relevant groups to integrate those specifications into the requirements, into our requirements. For example, we have already done some white paper for external publication, and of course technical reports internally on TSN integration with industrial networks. And currently we are working with OPC UA for certain APIs and requirement for integration. So in that case, for edge use cases and edge application location requirements, APIs, and our deployment architecture, we are currently considering the 3GPP, TS22104, 832, TR822, those industrial IoT type of requirements and specification documents, as well as ETSI MEC enterprise use case. What we have seen that those documents probably are not geared towards the edge applications or edge requirements at the time when it was written. So I think we hope the analysis and studies that we are doing, that the outcome would be useful for those relevant standards organizations, and we can provide input to those. So because the time is running out, I would like to give one quick example of the edge use case in the industrial environment, is that you could see that on-premise computer vision and AI technology usage, and that are in some cases is very critical. For example, AGVs are moving all around, and they might have camera attached to it. They might be carrying some chemical as well in a chemical plant, and they want to make sure they want to avoid any collision. So they would like to use the computer vision and AI technology to process quickly and take action. So those use cases, so latency sensitive use cases, bandwidth sensitive use cases, and the other kind of business edge location use cases are very important and critical in the case of industrial networks. As I mentioned before, at the end of the study, we will do the gap analysis and we will communicate with the relevant SDOs such as ETSI MEC, 3GPP, SA2, SA6, and SA groups, GSMA for contribution through the member companies. We are also considering some of the test beds and edge computing use cases. I would have a couple of questions for the 3GPP SA chairs regarding how we should collaborate, whether 3GPP would have a plan for moving forward with some document on age-specific use cases, or whether they would like to provide some solution for TR 23748, 23758. Those are age-related studies, and how can we collaborate on those when we have our requirements. So with that, I believe I'm over time, so I'll stop. These are the members in 5G SCIA. It's kind of growing fast, so it's close to 80 members now. And if you are interested, please join 5G SCIA and take a look at 5gscia.org for publications and information. Thank you for the opportunity, and hopefully next time we will have much more information on the edge use cases.
Indeed, thank you very much, Smita. That was an interesting presentation, and certainly use cases are very important, I think, to consider in this case. So next speaker will be Saeed Tabet, Chief Architect of Intelligent Connected Vehicles, Technology Lead of IoT at Dell Technologies, and Board Member of AECC. So Saeed, can you please share your slides and make a start?
Okay, great. Thank you so much. It's a pleasure to be here again, David and Stephanie. Thanks for hosting us. And also a pleasure to be here with my esteemed colleagues on the group here. My name is Saeed Tabet. I'm from the Dell Technologies as part of the Global CTO Office as Chief Architect. I've focused on a number of areas from edge computing, autonomous vehicles, robotics, and any of these future technologies from that are coming up, digital twins, etc. Within the AECC, the Automotive Edge Computing Consortium, which is kind of what I'm representing here on this call. I'm a board member and vice chair of Liaison Relationship Committee, and also work in a number of other technical areas there. Just wanted to kind of give you a quick overview, and I'll be able to share the slides as well, and a lengthier version of the slides, of course. So the Automotive Edge Computing Consortium was formed in 2018 with a variety of different members, from OEMs to MNOs, cloud providers, technology providers, and service providers, and others. As you can see, just this is a list of our members, representative. Our efforts focus on kind of bringing emerging services to life from an autonomous, from a connected vehicles point of view, and provide guidance to industry and as well as DO, standards organizations. So the AECC is not a standards organization, but we have a liaison with a few of those so that we can work with them around use cases and technology challenges and provide input through our white papers as well as our specifications that we generate. So basically, kind of we're looking to bring in this kind of variety of members to accelerate the growth of the connected vehicle market and then learn with each other. So this is kind of the approach that we took. Wanted to share with you a few numbers. When we talk about edge computing, I'm always fascinated how the automotive world in general, not just cars, think about trucks and mining equipment, all these other kind of things in different areas, that they really represent an interesting use case, both challenging technically for those of you who are listening, as well as from a business point of view. And we made some assumptions with quite a bit of research. There's a white paper that's available for you to read in detail. And looking at 2025 and probably beyond, we made some of these estimates about 100 million units of newly connected vehicles worldwide that would be put into the market. Each of these connected vehicles will need to communicate about 10 to 100 gigabytes. So think of about 1 to 10 exabytes, somewhere in between, maybe even more, on a monthly basis. When you look at that, you're looking at, we always talk about traffic in vehicles, but this is really data traffic and communication, telecommunication traffic, and it's a problem for the cloud systems and the various architectures. And there are a number of other kind of related problems to think about. So these are some of the forecasts we came up with, but in addition to that, we think from a business point of view, vehicles will be able to generate about $150 billion in annual revenue. And the data volume transmitted between the vehicles and the cloud, another number again, about 100 petabytes per month. So these assumptions, like I said earlier, based on the gigabytes that I mentioned before, but think about it, this is based on the only valid services that can be accommodated by current planned networks, current technologies, right? So when you think about the future, that's not enough. You are all involved and active in making this progress that we need, as you heard from my colleagues before as well. But future automotive services, in fact, will transfer much larger data volumes. So we're looking at what I call the zettascale problem, 1,000 times probably more. And again, like I said, we have a white paper, you could read that, and I'm happy to share things in more detail. When we look at these communications and these concepts, there are three areas that we consider. Obviously, ITS and as domains, right? IVI and big data. Think of ITS as the local communications, things like collision avoidance and adaptive cruise control is becoming more and more available in vehicles, as well as danger warnings, lane assist, things like that. On the IVI side, it's what you would think as your infotainment services or experiences as a user, navigation, your internet radio, and other types of data that is downloaded from internet and other nearby environments. When we look at this, the biggest impact from our perspective for the future is the size of the data. AECC is focused on that challenge, what we call the big data challenge. And it's driven by a number of use cases, and I will get to that in a moment. And those are kind of, when you think about this, the amount of sensors and sensor data and actuators in the vehicles, from 3D LiDARs and other types of cameras, et cetera, and think about the analysis of internal ECU state data, maybe for predictive maintenance on vehicles or being able to check the health condition. Those are all kind of functions and services that require tremendous volume of vehicle data, and that would come from many vehicles, right? I'll walk you through just quickly on the next slide on some of these use cases. So there are a few of them. High definition map is kind of our big one, and I'll explain why. I'll start with that, but I'll talk about all of these at least briefly. But we do have, again, like I said, there's a specific documentation that I'm happy to share. One of our working groups, working group 1 in AECC, is defining concrete use cases related to a lot of these service scenarios. and also requirements. I believe it's probably more now, as last time I talked to the team, about 30 use cases, over 100 requirements, and a number of examples. Think about data processing distribution. This can be used distributed network and computing to collect various types of data, like I said, from the vehicle. We have other things that we're looking at, the map data delivery. If we're talking about HD mapping, and the delivery is a very important aspect. Data integration, you heard earlier, kind of, for example, on the some of the vehicle communications, how often applications will have a hard time talking to each other. Integration is very important. Vehicle data localization, service migration, and a number of other things kind of really important there. Let me start with the HD mapping, and that's, like I said, this is kind of the darling of the biggest problem I guess we have, right? So when you look at the an HD map is a map that kind of integrates both static and dynamic data compared to what you would see today. Just try to envision that in the future. The cloud collects vehicle data, generates high definition maps, and sends that back to the vehicles. The vehicles themselves, particularly at the edge, there's pre-processing, right? Filtering, cleansing, aggregation, potentially some analysis that would happen there. Some data, you might not want to send it all the way back to the cloud. So there's kind of at the edge level, it's really an important topic to make sure we focus on. It also supports the distribution of the parameter set to the vehicle, the content delivery network, et cetera. And things, data compression, extraction, there's all kinds of other elements, routing, intelligent routing, I would say, and caching, and the delta for the updates. You don't always send the whole thing. There's all kind of issues there that are really important from that perspective that make up this topic. Why do we need them, right? When you think about all the services around connected EV vehicles, autonomous particularly, they need these resolutions of 10 to 20 centimeters, or even probably better. You know, it's kind of interesting when you think about the intelligence from an artificial way versus a human, as things that we think are seamless, that are a lot more difficult. Just think about making a left for an autonomous vehicle is extremely hard to do today. So this kind of some examples, as more vehicles and their sensors are deployed, we're seeing that more and more today. The challenge is kind of handling and extracting of the real selling critical information is important. And you have to think from this perspective, you need new types of ICT infrastructure. What we have today in data centers in the cloud and is not enough to support these kind of future deployments. And maintaining them, of course, it's going to be an interesting challenge, and that's why we started with this one. And here we go. I mean, talking about it. This is the white paper that we have. You can download it. So the approach we took and developed this assumption about the application's behavior, and then we introduced its processing patterns, the composition, and then kind of work from there, right? And it's really important, kind of though we made certain assumptions in this process, there is a lot more to it from that perspective. So it's just a kind of an interesting example, but it's a really good challenge when you think about it. Okay, so I'll talk a little bit just briefly so we can leave enough time for discussion maybe as we come back together. So intelligent driving is another use case or another scenario. There was a traditional definition called kind of a technology to be an intelligent journey to the driver. Think of it as supporting you as a driver in your vehicle, right? So the driver is kind of responsible for the actuation and using and enhancing your experiences, whether it's for driving or infotainment or other things. But when you think about it in general, when you talk about intelligent driving, talk about map updates and the alerts to road conditions and points of interest, maybe translating your text into voice, and a lot of these other things that are going to become more dynamic, not just the basic stuff we see mostly deployed today. So this is kind of interesting, and a lot of this is mostly covered by downstream data of the connectivity. The other use case is the V2 Cloud Cruise Assist. You heard a lot about that as well. So the meaning of V2 Cloud is network mediated vehicle-to-vehicle communication. So this is integrating kind of information. As you look at the picture, information that would come from a number of other vehicles that are nearby, right? The neighboring aspects. It gives you kind of this flexible model rather than using conventional dedicated V2V or V2I communications. But really, this is another kind of interesting example where AI and ML technologies, think about deep learning, maybe some machine learning algorithms as well, they would compute those data and determine information for autonomous driving assistance and share it as needed, where needed, and the vehicles that need it, et cetera. Just for those of you who are more techy, think about message bus in terms of a little bit more intelligence into it. So for the information delivery, the broadcasting, the information vehicles will be effective when they need the same information. That's all. Again, you got intelligence for intelligence in some ways. Yeah. The next one I want to talk about is mobility services. We heard quite a lot about e-mobility or mobility in general, and it means a lot of things to a lot of people. It started with more like real-time navigation assistance, right? Give me something that's relevant at that moment where I am with my vehicle. So that means better mapping services, the traffic flow, and potentially nearby consumer services, things that you would need. But it goes kind of a little bit further when you think about it, moving forward with that. Basically, in addition to a lot of these services, we can extend the user experience, things like ride sharing, of course, that we're familiar with, and multimodal navigation and so on. So there's kind of a lot of interesting examples here. Mobility is a lot bigger than that. Finance and insurance, that's another one. You probably hear a lot about a lot of these new type of services, even though it's not directly related to driving, but it is in some ways. It's a good example actually for new business models of connected vehicles, and it also connects to other edge business models or edge examples in different types of industries or different vehicles, right? Think about collecting, drivers' behavior and how people are driving, how often, and you can figure out their premiums, and you can potentially predict the risk or even simulate those things. And those dynamic premiums for consumers would vary, and maybe it helps in a number of ways. When traffic accidents occur, for example, the data could be used to identify the reason or the cause of the incident, and it could help reduce the cost of insurance. But even better, it could even help with policy making at the city level, or try to make things a little better and safer for mobility and so on. So this kind of brings up these additional examples. And of course, encouraging safe behaviors is always, safe driving behavior is always important from that perspective. I think that's my last slide. Yeah, here. So as I said, I'll share the longer version of the deck. I just wanted to be respectful of the time. The AECC website it's got a lot of things that you could download. Please reach there. Like I said, the AECC is about collaboration, and I'm very happy working closely with 3GPP, 5GAA, the IEC, a number of others through liaison organization setup. But also, if you have any additional input, comments, questions, please reach out directly. You'll find me on LinkedIn and others. Yeah, thank you so much. Appreciate it. David and Stephanie, back to you.
Yeah, thank you, Saeed. Thank you to all our panelists. So, ladies and gentlemen, in the panel, we're looking for short, snappy answers. Now that we move on to the interactive panel discussion, I think we'll move on to our first question, which is, how do you see the evolution of edge computing, and what will be the business drivers and models? Perhaps we can start with you, Leonardo, if you don't mind.
Hi, Stephanie. I hope you can hear me.
Yeah.
Yes. Okay. So first, I must disclose that I'm not really a business guy. I'm a standards guy. So everything I say here needs to be considered with caution. So I do think that, however, the edge computing will, let's say, evolve on different ways, probably on different places, also differently for different verticals. That's important to understand. We see, at least in the automotive side, that it's very relevant to see, regional characteristics and stakeholders involved. And this will set the scene for the evolution. What I do believe is that we won't see, let's say, from one day to the other, a full deployment of edge computing everywhere with full coverage, and mostly also not in the very end of the network, let's say. What I think it will happen is that we will have a successive deployment of edge computing getting closer and closer to the edge, right? And we already see today some deployments where, let's say, what we initially think as the edge is not exactly on the edge, but they do have properties which could be considered edge computing. And with time, we do think there will be a pervasive network of edge computing, like on the roads and the infrastructure, all around us, where you may have also different capabilities, right, to compute all the data that's being generated everywhere. And I think a similar approach of this diversity, how it will develop, is also applicable to the business drivers and models. And I think lastly, the specific use cases and applications will determine, who will be the specific driver. So I think it's hard to say there will be one specific business driver, but I think it will depend a lot on the application and the regional characteristics.
Thank you very much, Leonard. If you, Marie, would like to say something quickly about the evolution and the business drivers and models. Thank you.
Yeah, I can definitely talk about this, but clearly the opportunity was identified, many years ago, but it takes time until a new technology is actually adopted. But we have a lot of drivers, right, which relate to the digital transformation, both from the consumer side, from the all URLC transformation, all the digital transformation and mobilization of the enterprise industries, which is driven by automation. We have a continuous emergence of technologies that actually enable that, right? All the digital infrastructure like virtualization, cloud native SDN, 5G, edge computing, which we're now talking, machine learning and AI, and the fact that we have billions of connected things. So the need to move to the edge, the need to accelerate the experience and accelerate the operation and take a analytic at the edge or whatever, this is very clear that is coming. And also the market demands are increasing. So the demand is there. The opportunity is there, and now the technology is there. And as I said before, also we see that MEC is taking off. We hear a lot of new deployments. I believe it started more in Asia, and others are also deploying. We also see some collaborations between operators and some web scaler or hyperscaler, how you want to call it, which is really, really good. They extend their ecosystem to the edge, but still MEC has, as we defined in ETSI, has a lot of room to play in this collaboration, because the collaboration is still very much over the top, right? And very much based on a traffic volume, etc. And what MEC can provide in addition is also context information that can help to accelerate the performance and the experience that the applications provide. So yeah, so we're looking forward. It's a very exciting journey and wow experience. And I think collaboration across the industry is key to accelerate the adoption. No, because fragmentation always, slow down the process, see how which technology will win, etc. So I think we have now the platform for showing the synergy between the different activities. We started of course, with GSMA long ago, and GMN, and 5G-AA, and hopefully now with 5G-ACA, and now we have this synergic architecture with SE6, which really provides the platform now to have the acceleration of the technology.
Thank you very much. Samit, if you'd like to add anything from an industrial internet point of things.
Yes, very quick. Although I'm not a business person, but I think the business driver for the edge applications from the industrial 5G IoT point of view, I would think that it will drive applications will drive that where this application needs to be done, whether this needs offloading, whether it requires ultra low latency or low latency for that sake, so that the telecom operators can have distributed edge components, whether that would be inside the private networks, inside the factories, or close to the process plants, for example. That depends all on the application. So it's important is to understand those implications, use cases, as well as harmonization among different industrial forums. That is my short answer.
Thank you very much. Said, if you'd like to add anything from that? I don't know if there's any...
Absolutely. Yeah, thanks. Thanks, Stephanie. Yeah, absolutely. I think the edge is growing at a fast speed in terms of demand. The number of business level use cases that are utilized by verticals, whether it's manufacturing, telco, and connected mobility, autonomous vehicles, et cetera. And some of these that have been mentioned, Smitra, for example, about in the industrial side, and automation is more and more automation towards autonomy, right? Edge analytics and predictive maintenance and image, video processing, device management, digital twins, infrastructure control. All those are key use cases that have some horizontal level of technical capabilities. And from a business point of view, that's really important, particularly in some verticals, as it's seen more as a continuum from cloud to edge, where a lot of these expectations, at least, are going to be very important. I think the work that's ongoing would help educate the end users and the consumers, enterprises that are going to be deploying this. So the more and more we're getting there in a sense that we're going to see a lot of these additional capabilities. Yeah. Thank you.
Yeah, thanks very much. I think David has got the next question. Thanks, Dave.
Yeah, thank you. In terms of this evolution, business drivers and models and so on, we all know this elephant, not in the room, but around the world, is coming with the artificial intelligence label. And the question really is about, is artificial intelligence a building block for MEC? Is it driving MEC? Or is MEC enabling AI? Which way around is this? How do you see this? I'm going to start with you, Said.
Sure, that's a good question. You know, I've been in that world of AI for way too long to see all these transformations, but you're absolutely right. I think it isn't an elephant, and we continue to work through it. In my view, it is important. It is a building block. I don't think we can ignore that. There's a lot more work to be done. And I'll put it also in another picture, if you will, around the concept of trust, right? You know, trustworthy AI in some ways, where a number of things are going to be very important as we combine, bring those two things together. And I believe that you know, for MEC to continue to be more deployed more and more and successfully, it's more important in production and operational environments. We have to figure out kind of the place of AI and how we use it and how we can build that trust and security aspects and privacy aspects as well to enable that capability. I think that's the part, to me, that's important from that perspective, David. Yeah.
Thank you, Said. Nurit, I think you'll have some words to say on this one.
Yeah, no, clearly. Yeah, so at the edge, AI plays a very important role. If you think about, for example, in the industrial IoT case, so what you could have at the edge is to use AI machine learning to do the real-time analytics at the point of capture, and they have a minimum cloud ingress save cloud ingress bandwidth and reduce it to the minimum, and take also a correction action very close to the case. So this is just an example. Also helping to understand what is happening at the edge and trying to extract meaningful information from that for the applications can also be a good use case to leverage AI and machine learning. So there is a lot of room to utilize it there. And if you recall what I proposed at the end, also the co-hosting of the MEC applications and the RIC application on the same platform. So you actually can use the AI machine learning to optimize the applications, the behavior, the application's experience, but also to understand how to use it to optimize the run itself with AI machine learning. So clearly there is a big role for AI machine learning at the edge.
Yes, indeed. Thank you very much, Nurit. Please, Gabriel.
Very nice, stable. Yeah, the Edge Gallery has provided several AI-related capabilities regarding dynamic or static objective recognition, or to color a graph, or some other AI capabilities. We have planned to provide more AI capabilities in Edge Gallery. I think AI is not only related to the open capability, but also related to the orchestrations, OSS or BSS modules in edge computing. Now it's I think every company will place AI in a very important role in not only edge computing, but also in a network or cloud scenarios. Definitely, I think AI is very critical in edge computing scenario.
Yeah. And while we have you online, Gabriel, where do you see the business drivers from an Edge Gallery perspective?
It's not only in application level. In application, we provide AI capabilities or AI-related SDKs regarding different hardwares. For example, the TPU or the Ascent computational unit from Huawei or other computational unit. But it's also related to the management components. Everyone every company want to provide a zero-touch, operating system. That will mainly depend on AI algorithms.
So we're asking each panelist for their takeaway from today's webinar, and if you could also give an indication of what advice you'd give to industry verticals for their product rollout planning. So we'll start with Saeed, and then we'll do Sunita, Nurit, Gabriel, and Leonardo. Thank you.
Thank you very much, Stephanie. I appreciate that. I think the takeaway for me, this was kind of very interesting, first of all, and I think a productive discussion. Lots of great questions that came up from the audience, and it's an important topic. I think to me, I would love to see continued discussions around this as we move more and more towards the edge as we see it. That's really important for us to have clarity, to figure out the collaboration areas, the use cases, the role of AI, as we said, with Nurit gave some examples, as well as Gabriel and Sumitra. And I think that these are going to be very important things as they help us as we move more and more towards the edge, dealing with some major challenges, both on the hardware and the software, the application level, the business side and technical side. So that aspect to me is really important. And my takeaway is, like I said, I'm very pleased and happy to be here and to contribute to what we can from our side. So in terms of advice, I think as we move more and more to the edge, for those products that are coming up, and particularly as you look at your roadmaps and as you work on the edge, you're going to see a lot more focus, a lot more interest on how close we get to that level of precision around your data, around your requirements, the use cases and the scenarios and the experiences you're providing to the consumers of those services, of those applications, or the orchestration of the services that needs to be more and more automated, how we enable the capabilities to provide that level of digital trust around them. But in addition, kind of being able to communicate a lot of these enabling and future important technologies that continue to advance and change. I think that's going to be very important. So that would be what I would say. Just like I said earlier, Edge is moving very fast, and there are many, many verticals that are growing at a fast pace, and it's going to be very interesting to make sure that we look at those roadmaps and product rollouts to be successful. Thank you, Stephanie.
Thank you, Saeed. So Samita, what would be your takeaway and your advice to vertical industries?
Sure. So I thank you for the opportunity for being here. I think it is a very productive session as well. And for me, the takeaway is understanding the edge components, use cases on the other areas in general. For example, automotive industries and overall ecosystem. Above all, I am very glad to be here because I was looking for contacts and knowing more about ETSI MEC, and I think I have learned a lot on ETSI MEC, and I also know in the future who to contact if we need more. Edge Gallery perspective on the ecosystem system development is also interesting, and so I also learned about AECC. So overall, I think it's great, and of course, you know, Stephanie and David, we know that we can contact us on the 5G IA and the public safety related. So that is the takeaway for me in general, and I will use that for 5G SEIA edge use cases going forward and the other studies. For the recommendation, I think the companies or industry verticals that want to move their product, few things comes to my mind is that they need to know their requirements, develop ecosystem around it, and then third thing is very important that they follow the standards and industry forums so that they know things that are being worked on are or the product that is rolled out, they are compatible, they are interoperable.
Thank you very much, Nurit, if you could.
Yeah, thank you very much for the opportunity to present here. It was a very limited time slot, so I had to rush a little bit, and I'm sorry for that. And also, I just managed to give some pieces, so of course I'm happy to have a further and offline discussions with anyone that is getting interested in that. I was very encouraged by the presentations today because it shows the value of the edge. We understand that there are a lot of interesting use cases. We see a lot of work that is done in the industry, and we believe that the ecosystem is being developed, and it still have to wait to be developed, of course. And I actually see some good signs already of harmonization. And this is very, very critical to enable this adoption of the edge at scale. So we see that 5GA is working on automotive, or we have another organization on that, but still they can utilize what we have done in ETSI MEC, and of course the 3GP network. Was the same for the 5G CIN. I would like to encourage here to have a strong collaboration between the organizations. We see the Edge Gallery, which actually implements based on this synergic architecture, which is a very good sign, and actually reconfirm what Delaware had in their report end of last year. So it is very, very important to ensure that we avoid unhealthy industry fragmentation, and that we align and leverage synergies and offer common practices and tools for the developers, because you can offer a very good and attractive environment and very good tools, but if these are not common, it will be hard to adapt because the consumers, the enterprise developers, anyone else that is using the APIs wants to have a common practice how to use it, and they don't want to have it to tailor it to particular environments. And another aspect is that it's very important that the platform that we are running can run on every cloud and can be deployed flexibly in different environments to provide the value. We have seen the example of deploying it next to the near Tamrik, but of course it can be, as I said, flexible and multiple deployment options that can be utilized. And we see the role of AI machine learning. We heard about automation. Yeah, zero-touch automation is critical for the edge because of the number of edge platforms and the number of applications residing there. So definitely zero-touch automation becomes a critical also to accelerate to ensure that application is running in the right place, meaning that a place that satisfies the requirements and at the right time, meaning that if, for example, there is an event that where the requirements cannot be satisfied any longer, so we can relocate the applications. So for example, in handover event or etc. And also that we enable this MEC to make a communication in order to satisfy the needs, for example, of applications like V2X, etc., where we need to have this communication to align the situation and trigger some actions. So a lot of way to work yet, but harmonization, working together, it's critical for the success.
Thank you very much, Gabriel. If you could give us your takeaway and advice. Leonardo, maybe you'd like to say something? Yes.
Yes. Okay. So let's start with the advice and to verticals and stakeholders. I think this is something we already see by the very existence of associations like 5GA, 5GA-CIA, and so on. AECC, that one important thing for verticals and stakeholders is that they need to collaborate, right? For edge computing, this is essential. We see that this is a technology that really needs the collaboration of everyone, or all stakeholders involved in order to really happen, as it happens also with many new technologies. And since we are talking about vertical, it's clear that we have overlap of different industries with very different business and business models. And this makes the collaboration even more essential in order to make sure that the service provided to the final user is the best one on affordable price and so on, right? So I think collaboration is essential. It's already happening, but maybe it needs to be more intensive. The verticals need to be very open on sharing their needs and requirements with the telecommunication industry. I think this is very important. And my takeaway is that it really seems we are on the right path toward collaboration, but it's also clear that there is still a lot of work to do. We need to have a better understanding what the different verticals needs in order to also converge on something that is really feasible and affordable to everyone. Right, the investments are pretty high in order to build up this infrastructure. We know in telecommunications investments are extremely high, and this is coming on top of all of that. So all these verticals need to talk to each other, and this forum here, for example, it's a very important one to provide this exchange and insights on this different industry. And thank you very much again for the invitation, for participating. It's a very interesting experience.
Thank you very much, Leonardo.
All right, the first poll we'd like to present you with is which verticals you expect the first implementations to come from. Which ones do you think are the first ones in which this is going to happen? So it looks like it's manufacturing is first, and close behind are both warehouse and broadcasting. With the other ones,
where we refer to more like gaming and VR and AR actually. Yeah.
Yes, could
So
very
it
well
was
be.
kind of an umbrella term. I
Yes,
forgot
yes.
automotive. I'm so sorry. My fault. I apologise profusely for a wonderful automotive community.
Well,
I'm sure
that
that
means
would, yeah.
people won't have to go out on a limb, I
It,
No,
guess.
no.
it would win. It would win.
Yeah,
right?
well, I know it
Yeah,
would win.
let's just say it's the clear winner, so we didn't
Yeah.
bother to put it.
Okay.
Okay, here's another one we would also like to ask you about.
Yeah.
What are your priority requirements, your priorities for edge computing? What do you think is important for your needs? So interoperability, continuity, latency, and high reliability. And finally, being able to transfer processing large volumes of data, of course, which will depend very much on the use cases,
Yeah.
whether it's high D maps or something completely different, which doesn't require it.
And these things may not all be available at first deployment, obviously, because we'll see things being deployed slowly. But think about,
keeping in mind that they won't always be available, all be available at once. So which ones do you need first?
So I'd like to pass on a really big thank you to our super panelists this afternoon. You've given us some great insights. Just a reminder, and everything will be available. We'll come back to you when everything's ready and publicly available. I've posted in my email in case you have any other questions or comments to make, so please do get in touch with me. I'd also like to just remind everybody then this is part 2 of this webinar series, is looking at 3GPP standards, the collaboration between the organising associations as market representation partners has always been very close with 3GPP.
So low latency is the clear winner. So people are most interested in applications that are going to require low latency.
Oh, that's interesting. Thanks very much, everybody.
Yes, so much more than processing power, the low latency is going to be the deal maker this time.
Yeah, and I think we can share our own take. I'm really glad that we got the ETSI perspectives in, because this paves the way for Thursday's webinar. It's great to see this collaboration taking place a lot already. As Leonardo said, this forum is important to help keep pushing for more collaboration, and that's definitely what we'll be doing in the future. So thanks everybody. Thank you to our audience. Thank you to our great panelists. And with this, I think we can close the webinar. I don't know if you want to have a final statement, David, on your side.
Yeah, just to say thank you, everybody. Thanks to all the speakers. Thanks to those who took part in the attendees. So yeah, great. Thanks a lot.
Yeah, and it's great to see also the panelists already talking about collaborating more between themselves. I think that's also a great outcome of the webinar. So thank you, and we'll look forward to meeting you again on a future webinar. Thanks again, everybody. Bye for now.